Hey kiddos, in this video we're going to go over or be introduced to the Pythagorean theorem as well as how we can identify certain parts of the triangle that are going to help us to know whether or not we can apply the Pythagorean theorem or not. So when we're looking at this particular shape, we know that this is a right angle, and the reason why we know that this is a right triangle due to the fact that we see the following symbol here. Now these two parts, this is what we're going to call, or this is what is called a leg, because it's this side of the triangle as well as this side of the triangle that forms the right angle. So these two are called the legs of the triangle. Now, when it comes to this part that is opposite of the right angle, this is what's referred to as the hypotenuse. So in your notebooks, if you could please write the following. Oops. That should be an E, not an H. Let's erase that and get that correct. So this side of the triangle, the longest side of the triangle that is opposite the right angle is called the hypotenuse. And then these two parts of the triangle that form the right angle are referred to as the legs of the triangle. And so when we look at this right angle or this right triangle, we can see that the sides of the triangle or of this triangle, we see that this first part here is 4 units. This part here is 3 units, and we're told that this is 5 units. So when we're transposing, or when we're taking this part here that's been shaded in, we see that this part here is going to be equal to 4 units. This part here is going to be equal to 3 units, and our hypotenuse is equal to 5 units. And hopefully, based off of what you did in class the other day, you're able to recognize that, that the sum of the squares of the legs of the right triangle was equal to the square of the hypotenuse. I'll say that one more time. That the sum of the squares of the hypotenuse, meaning when we square this side and we square this side, which were the two legs, so 4 squared and 3 squared, that it was equal to the hypotenuse squared. That 4 squared plus 3 squared was equal to our hypotenuse, which is 5 squared. So our key point for today is the sum of the squares. So once more, the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So 4 squared is 16, 3 squared is 9, 5 squared is equal to 25. The statement is true. 25 is equal to 25.